Let's talk about Python's t-strings. Python has had many different waves of string interpolation over the years. It's had %style string formatting since pretty much the beginning. Then Python 2.4 added a template class to the string module. And Python 2.6 added an even easier version of string formatting with the string format method. Then Python 3.6 added a new string formatting syntax with f-strings. Now, Python 3.14 has yet another string interpolation syntax with t-strings. Well, sort of. Unlike f-strings, t-strings don't actually make strings, but they are useful. T-strings are for lazy string interpolation. Python's f-strings immediately interpolate the expressions within their replacement fields. That's the bit between the curly braces. Usually this eager interpolation is fine, but sometimes it can cause headaches. Let's say we're reinventing the dedent function from Python's textwrap module. Just like the original dedent function, our version removes all common indentation while maintaining the relative indentation of each line. It works, but if we use f-strings with dedent, we might have a problem. If we take a string that has multiple lines within it, and we try to use it in an f-string, and then pass that f-string to the dedent function, we won't end up with the unindented text that we were expecting. Our output string looks all weird. The first line of our replacement field string is indented, and the other lines are only indented as much as they were in the original string. Also, the entire output string wasn't actually dedented at all. Our f-string put a string that lacked indentation inside of a larger string that had indentation. By the time the resulting string was passed to dedent, it didn't look like something that could actually be dedented any further. So currently, our dedent function has no way to know what the original f-string looked like before it was interpolated, and then retroactively indent the replacement fields before dedenting the full string. This is where t-strings come in handy. F-strings return strings. T-strings return string.templatelib.template objects. If we loop over these template objects, we'll get a mix of strings interleaved with interpolation objects. This allows Python developers to make tools that can accept t-strings and can pre-process the interpolation parts before combining all the parts together. So it's possible to make a dedent function which accepts a t-string and properly dedents it the way we're probably expecting it to. This version of dedent was able to see that the replacement field was relatively indented within the larger string, but the actual contents of that field weren't actually indented, so they needed to be properly indented before we could dedent the rest of the string. This custom dedent function was specifically designed to work with t-strings. It does wrap around the version of dedent from Python's textwrap module, but it also needs to carefully process the interpolated value appropriately depending on its contents and where it appears within the bigger string. You can actually find this version of dedent as a library on the Python package index. It's called Better Dedent. It probably has bugs, so feel free to report them to me if you find any. T-strings are primarily useful for the maintainers of libraries that are used by other Python developers. Anytime you're designing a tool where you need to pre-process smaller input strings before combining them to a larger string, like escaping SQL, HTML, or regular expressions, you might want to use a t-string. Or if you need to delay string interpolation for some other reason, like Python's logging module does, t-strings could come in handy in that case as well. If you don't maintain a library where your users would benefit from delayed string interpolation or automatic pre-processing of inputs, then you don't need to think about t-strings until a library tells you to use one. Writing a t-string is pretty much as simple as writing an f-string. You just use a t instead of an f. But using the template object that you get back from a t-string isn't nearly as simple as using a string. You probably won't use t-strings and template objects in your own code, but you might pass them to code written by others. If a library is specifically designed to accept t-strings, you'll pass it a t-string.